What's up, math scholars and math haters? This is Mr. W. Today we are going to start Discrete Mathematics, which is a senior level math course that North Carolina lets you take after you're done with Math 3. That's one of a couple different options. Discrete Math, I personally think, is the most fun because it has the most real-world applications and you can learn the most about how math actually comes out in the world around us and not just in school and in math classes. But we're going to start a unit on probability. And we're going to start with a big idea called the fundamental counting principle. Essentially, if we have a big thing, like the three examples I'll give will be a fancy dinner with a tiny menu, an outfit, choosing an outfit for a day, and then choosing a passcode for your phone. If a big thing like this can be broken down into smaller parts, so the different parts of the meal, or the different items of clothing you'd put on your outfit, or the different digits in your passcode, we're going to multiply the possible outcomes of each of those small parts. So each number of choices for the parts of the dinner, or your outfit, or the number of choices you have for each digit in your code, we're going to find those possibilities, multiply them all, in order to get the total possible outcomes of whatever the big thing is, whatever the big total thing or idea is. And the first example I'll use of this is going to a fancy party where you get a dinner and you look at the menu and you're just like, wait, what's going on? There's only like 4 things on here. Because usually, these fancy dinners will let you choose, for instance, let's say a meat or vegetable entree, and then for your sides, you'll get to choose between like mac and cheese, fries, or corn, or something like that. And using the fundamental counting principle, the way that we can figure out how many possible dinners you can make, how many different choices of a total meal you can have, is we're going to take the number of possible entrees, so just 2, meat and veggie. We'll multiply it by the number of sides that you can choose from, mac and cheese, fries, and corn, so that's 3. We multiply these together, and we get a grand total of 6 possibilities for meals. Now, I do want to use this first example to demonstrate one idea that is called a tree diagram. You might have seen this before, but essentially this is just a way of visualizing and actually letting yourself see exactly what these 6 combinations are. So I'll go ahead and start this by making 2 branches from the very beginning, one that goes to meat and one that goes to veggie. And from there, each of these is going to branch out into 3 possibilities. So from meat, if we order meat, we can get mac and cheese, fries, or corn. If we order veggie, same thing, we can get mac and cheese, fries, or corn. And this will actually go ahead and give us each possible combination of meal that we can get. So if you get meat and mac and cheese, you got meat and mac and cheese. You can get also meat and fries, meat and corn. And down here we have all the veggie entree choices. So that's veggies and mac and cheese, veggies and fries, and finally veggies and corn. So those are all 6 possible meals that you could get. And a tree diagram is one way that you can actually go ahead and let yourself see each of those right in front of you. This does not really get practical when the numbers get bigger or when you have more than 2 choices, which is what the next example of the fundamental counting principle that I'll go over will actually deal with. So here's the second fundamental counting principle example, and it deals with outfits. So we're wondering how many possible outfits we can make if we have 6 shirts, 5 pairs of pants, and 2 pairs of shoes. Didn't write pairs for the sake of space. So we will go ahead and write out the different parts of our outfit: shirts, pants, and shoes. We have 6 possibilities for shirts, 5 possibilities for pants, and 2 possibilities for shoes. So 6 times 5 times 2 gives us a total of 60 possible outfits. And again, I'm not going to draw a tree diagram for this, because like I said, it gets pretty tough and impractical, and you hardly ever have enough space if you have a problem like this, where it comes out to a ton of possibilities and you have 3 different parts to your big thing that you're trying to make. But anyway, that was the second example. And I did also want to show that even if you have 3 parts to something, or 4 or 5 or whatever, you do the same thing. Just find the possibilities for each part and multiply them all together. Okay, so here is the third fundamental counting principle example. Picking a passcode for your iPhone. We're going to look at which option is more secure. Having the passcode where you put in 4 digits, like your PIN number or something like that, or having a passcode that is made up of 6 characters that can be either letters or numbers. Now, if you see a problem like this, or if you deal with anything working with digits or characters, like telephone numbers, I think would be another good example of this, you're just going to you're going to have to go ahead and say, okay, I have 4 digits. That means each of them, first digit, second, third, and fourth, has some possible number of choices. Now, if we're working with digits, there's only 10 digits we can use, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for the first digit, we have 10 possibilities. Same thing for the second digit, same thing for the third digit, same thing for the fourth digit. Just like with each of the other examples of the fundamental counting principle, I'm going to multiply my possibilities for each of these parts, each of these digits, all together. And 10 times 10 times 10 times 10 gets me a total of 10,000 possible passcodes. Now again, just to reiterate, just like with the outfit example where we had 3 different parts to our whole thing that we were looking at, we just had to find the possibilities for each part and multiply them together. Same thing for these passcodes. But what if we decide to go with the other option? And I think there might be a third on iOS, but I'm not entirely sure. But let's say we go with this option where we have 6 characters now. How many possibilities are there for that? Well, since there are 6 characters, I'm going to have to start by making 6 blanks. First, second, third, fourth, fifth, sixth. And these are not the numbers I'm going to multiply together. Just didn't have the room or the time to write first and second and so on. But now if we're looking at characters, these could be any of the 10 digits, or they could be any of the 26 letters, which means that each character now has 36 possible choices. And I'm still going to go ahead and multiply all of these together. And if you're keeping up with me on this and you type this in your calculator, you can type it like this, or you can type it as 36 to the 6th power, because we're multiplying the same number, 36, by itself 6 times. Either way, your answer is going to be very, very large. Specifically, you should get an answer of 2,176,782,336 passcodes for this system instead of the first system. So if your issue is security, I would go with the 6-character passcode, because there's so many more possibilities and so many choices for each digit, and someone who is trying to hack into your phone would have a much tougher time finding a 6-character passcode than a 4-digit passcode. So those are some examples of the fundamental counting principle. I hope that this can be helpful to you if you're using this to supplement your studies. If you're my student, then you should have your assignment already.